Yeah. Okay. So, and really, it was young adults. Okay. So, she wanted to know young adults' favorite type of music. Okay. So, her intended population was the young adults. Okay. Determine the potential sample bias. So, what was wrong with what she did?
Went to a music concert with only one music.
Yeah. So she went to what kind of concert? What kind of concert did she go to?
Country music.
Country music. So chances are, okay, if you're like into hard, heavy metal, okay, you're probably not going to be at a country concert. Okay, if you listen to a lot of rap music, again, you're probably not going to be in a country concert. Okay, so that is what's wrong with her. She asked people as they were leaving a country music concert, which means their probably favorite music is country. Okay, so that is what's wrong with her question. Okay, number 3. Okay, members of a neighborhood committee want to know whether they should spend money to renovate the playground. To find out, they ask people as they are picking up their children, or picking up at an elementary school bus stop. Identify the intended population and determine the potential sample bias. Okay, so who is her intended population? Who's gonna gain something from this? Who is she trying to ask? Jerry, go put that up. You guys are being quiet. It's gonna take all day. Yeah, the members of the neighborhood. Okay, that's her intended population. Okay. We're just gonna say the neighborhood. All right, what is the potential sample bias? What's wrong with this? I'll stand here all day for those of you guys that have not met me, so let's go. If you're working on number 2, then get on number 3. Okay, who's the potential sample biased?
Because they're asking people about picking their kids up off school.
Yeah. Okay, so, and I wouldn't necessarily say that's wrong. However, what if their kids are homeschooled? Okay, are you going to get that same thing? Okay, what if they're not even school-age children yet? Meaning, if they're younger than kindergarten, they're probably using the park. Okay, but they're not going to be at the bus stop yet. Okay, so we'll just say this bus stop. Okay, go to number 5. An online survey asks, do you support building a new football stadium which will be funded by increased taxes? What is the potential sample bias in this question? What's wrong with this question? wrong with the question? Let's go. I'm gonna start calling on you guys, then you're really gonna be embarrassed. Okay, do you support building a new football stadium which will be funded by a tax increase? So do all of you guys in here play football? Okay, so I can take extra money out of your paycheck even though you don't like football?
No.
Why not? You don't wanna do that? You don't wanna pay for a new football stadium? That's what they're saying. Okay, so, that's what's wrong with the question, okay, is that tax increase. Okay, so a tax increase is gonna take more money out of my paycheck, even though I don't even live in this neighborhood, okay? Whose interest is gonna be served by this? So who has something to gain if we get a tax increase?
The football players.
People who like football. Okay, or football players or whatever, okay? Anybody that is like pro football, okay, has something to gain. If they play football, if their kids play football, okay, if you wanna go see football, those people are getting something from this, okay? The people who don't like football, now they're gonna have to pay more taxes, okay, out of their paycheck to fund this football stadium, even though they may not want it. Okay, number 7, Carrie asked students in her school, do you prefer reading physical books or ebooks on electronic device? Okay, identify the potential sample bias. Okay, and this one's kind of tricky, but there is none. Okay, there's nothing wrong with this question. Okay, there's nothing wrong with this question. She's just simply saying, like, she's asking the whole school, okay, would you like an ebook or would you like a physical hand copy of the book? Okay, whose interest may be served? The school. Okay, the school has something to gain if they know that what the majority of the student body or staff would like. Okay, that's the only person that has something to gain from this. But as far as like what's wrong with that question, you're getting a school book either way. Okay, it's just a preference of which one you would like. Number 9. Marisol counts the number of red cars she passes on her way to school each day for 10 days. The numbers are 5, 2, 4, 3, 15, 3, 6, 2, 4. Okay, find the mean, median, and mode of the data set. Okay, so start with the mean. Add them all up, and we're going to divide by however many there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Add those all up, and then hit equals, and then hit divide by 10.
$4.8.
4.8.
I got it.
You got 4.8 too? Okay, so 4.8. Okay, so that's saying on average, she sees 4.8 cars every day. So between 4 and 5 cars every day is what she sees on average. Okay, the median. You can put them in order from least to greatest and find the middle, okay? Or you can do like the big and then little and cross them out, okay? So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and so you have 2 left there in the middle, which is 4 and 4. Okay, so you would add those up and then divide by 2, which is going to be 4. Okay, and then the mode, which number occurred the most? 4. Okay, now, the second part is where we need to talk about. It says, which measures is appropriately to accurately summarize the data? Okay, so, the mode really doesn't affect anything. You can have a 4 up there 500 times. It's not going to change the stuff. Where you're going to see a change sometimes is the mean. Okay, because if on day 10 she sees 100 red cars, okay, that shoots the average up. So sometimes you guys are in high school, okay, so sometimes you guys will take a test and the teacher will be like, oh, I curved everyone's test, okay? What that means is, and they'll even do it for grades. I don't, you get what you get, and that's just the way it is, okay? But if everyone in this room gets an F, and then you know there's that really one smart person, they're gonna get an A, what that does is screws everybody else up, because when they went to go bump up the score, you can only get 100. That's as high as it can go, okay? And so they can't bump everybody up. Well, if everybody gets an A and one person gets an F, well, then that, you probably didn't study, okay? But when everyone gets an F and 1 or 2 people get an A, and that really messes up that mean, okay? And so what number up here just does not fit? The 15. And what the 15 does is make the mean higher. See how these are both 4 and 4? Well, now this is 4.8, okay? And so when we have what they call it an outlier, okay, somebody that doesn't fit in and it's way bigger than everything else, okay, it makes that mean shoot way up, okay? And so which measure or measure appropriately accurate, okay, the 15 really starts to screw up that mean, okay? And it doesn't look that bad on this one, okay? But if it was 100 and you put all of these and then plus 100 and divided by 10, it's gonna make your mean shoot way up, okay? And so on this one, there is none. These all accurately summarize the data, okay? But in a lot of cases, when you have one that's gonna stick way out, it's gonna screw up your data set, okay? Let's look at number 11. Okay, a college-age professor made all of this list, okay? Find the mean, median, and mode. Okay, so add all those up, and then we're gonna divide by however many there are. There's 15. Okay, so add all those up and then divide by 15. And what'd you guys get? Well, if you're not done yet, that's fine too.
$18.6.
18.6? 20.6?
18.06.
I don't know what it is. You got 20.6? Is that what we're going with? I don't know what it is. I won't know until I do the answer key. Somebody get something different? Okay. The median, okay, the middle number. $19. Okay, and the mode looks like 19. Okay, what number does not fit? Yeah, the 40, okay? It's almost double what the highest number of everything else is. So the next highest number is 20. 40 doubled that, and so it made the mean go up, okay? Okay, 13. A restaurant compares the total number of days worked by 2 employees. Okay, so we have employee 1 and employee 2. Okay, they made graphs of the total number of days each employee worked over several weeks. Do the graphs misrepresent the data? How does the difference affect the interpretation? So, take a second and look at the graphs. At first glance, who do you feel like worked more? Employee 1 or employee 2?
It looks like employee.
It looks like employee 2. However, what do the graphs actually say?
They're the same. Employee 1 and employee 2 walking away the same.
They're the same,
No,
okay?
not.
Okay, so at 6 weeks, we can see he worked a little above 15 hours, okay? At 6 weeks, he worked 16 hours, okay? And so this is probably 16. They're the exact same. Both employees worked the same amount. However, they made it look like employee 2 worked more. And that's all that this fancy question is asking, okay? So do the graphs misrepresent the data?
Yes.
Yes. Okay, how does that difference affect the interpretation? So what did you think originally?
That number 2 walked on it.
Yeah, okay, so it makes us think, employee 2 worked more. But didn't. Okay, and then last one, 15. If the same set of data is graphed on a scale that starts at 0 on the y-axis, okay? So here's graph 1. It starts here at 0, okay? With a scale that starts at 50, so this one starts at 50 and this one starts at 1, and we shoot up, what does that representation have effect on the data? Okay, so one starts at 50 and one starts at 0. Okay, and what does that do to the data? And this is kind of a crappy picture, but it's the same concept here. This goes from 0 to 300, and this goes from 0 to 100. So what does that do to the data? And we just did one. What did it do? Okay, and the same thing happened here. It went from 0 to 2. This went from 0 to 5. What did that do to the picture?
And it looked like one did more than the
It makes
other.
it look like one is different than the other when they're actually not, okay? And so when one starts at 0 and one starts at 50, okay, it makes the data look different when it's not. Okay, you guys have